Well, as you can see, I've got my mini mill tore apart. Ever since I converted to CNC, I've had problems with it, particularly on the Z-axis. The Z-axis mounted here with the excuse me, ball screw off to the side that mounted to this dovetail part that slid up and down with the give. And I always had trouble with it skipping and hanging up, and you'd be losing steps and just screwing things up. So I had to be very careful when I used the Z-axis and go real slow. So I decided to tear it apart, see if there's any way I could figure out how to get the ball screw into the center of the part that slides up and down, which hopefully would make it less of a problem as far as skipping. It'd be more smooth pulling it up and down. So I have no idea as of yet how I'm going to do that. Bore a hole through here, run the rod through there, and somehow mount this or a new aluminum piece on the bottom, and make a new piece up here to mount the motor to without interfering with the spindle motor. So the first thing I'm going to do is just get it unbolted from the table, take the plexiglass surround off, get this cleared off where I can lay it down and see everything what I got to do better. I think what I'm going to do is get some measurements off of this thing and try to model it up in Fusion 360 to get a better idea of where to put the ball screw rod and where to mount the plate at the top and how to mount it to allow for the clearance for the spindle motor and all that stuff. So I think I'll get some measurements and then take it from there. If I'm able to do what I'm planning, which is to mount the ball screw in the center here, I'm hoping to be able to use the same block of aluminum that has the ball nut attached to it to mount to the top of this. But it's awful thick, so I'm thinking I can machine it down. And in doing some research on this Thompson ball screw, the number on it shows that the ball screw is actually threaded into this piece of aluminum. So I could probably unscrew that out of here and leave it on the ball screw, and then I could machine this down on the CNC router, hopefully. So I need to take this apart to get this screw out of this housing here. Well, after making a drawing on the computer in CAD, I was able to determine where the hole needs to be for the ball screw to go through this part of the housing that raises up and down on the Z-axis. So I'm going to start out with a center drill and work my way up to a 1/2 inch hole through the top part of this. Then we'll take it over to the CNC router and got a program ready to go from that 1/2 inch hole to open it up to 28 millimeters for the ball screw nut to fit in. After we do that, we'll have to make a little mill another little spot out to the one side here for the part of the ball screw nut that has a little thing that protrudes out where the balls travel back and forth to recirculate. So we'll get started on drilling this hole now. This cast drill is pretty easy with a good sharp bit. Okay, I've got the part clamped down onto the CNC router table and everything lined up, getting ready to start the program to bore out the hole from the 1/2 inch to the 28 millimeter. Started out at a little over 3,000 RPM and I just bumped it up to 4,500 RPM. Seems like it's cutting a little bit better now. I'm only taking 5,000 depth of cut. So it's going to take quite a while to get through the thickness of that. We're about halfway through now at 445,000 deep. We got to go to feet. I had to change end mills to from a 1/2 inch to a 3/8. I had a lot of chatter earlier and it kind of jerked the part back a little bit. So I had to reclamp and reposition everything and like I said, change the new bit to the chipped tooth on the 1/2 inch bit. Well, the hole turned out pretty nice. Well, I made a big goof a while ago when I was cutting out that hole. I had positioned the hole from this edge here, and it should have been from this edge here, which is a recess that straddled the rack on the rack and pinion on when it was a manual mill. So I should have positioned the hole from this edge. From this edge, and I positioned it from this edge, so it was too far forward. So I'm in the process of cutting the hole back further where it should be. So what that'll do, that extra cutaway in the front will give me clearance for the part of the ball screw nut. This part right here, which protrudes out from the diameter of the ball nut. So hopefully that'll give me enough clearance for that, and I won't have to recut anything for that. Well, we finished cutting it the second time. Let's see if this thing will fit in here now. Oh yeah, plenty of clearance for that thing in the front. And it looks like we got just shy of 2 millimeter from this back edge, which is what I was shooting for. I was shooting for about 1.5 millimeters. So I got about 1 3/4 millimeters, so that's pretty good. So that part's done. Well, let's get this unclamped and cleaned up, and we'll have to turn it over and bore from the bottom side the thickness of the ball screw rod itself, which is a little over 15 millimeter. So I've got I found a 5/8 drill bit that I've got, so I think I can maybe use a drill bit to do all of it, and won't have to put it back on the router here because it's kind of a pain. It takes so long. I might be able to just drill it, but we'll see here. Let me get it taken out and cleaned up. I don't know how well this is going to work drilling this on this end because we have such a narrow spot here and then voids under here. I'm not sure how the drill bit would do. It may tend to lead off, but at least if we can get a hole started here, then we may could come back and lay it down and mill this out with the router, CNC router with an end mill. So we'll see how it goes. Well, it's not quite big enough for the ball screw rod to go through.
Almost, but not quite. It'll be like that. Almost. In fact, it clears right here, but it's almost rubbing, so I think I'll clamp it down on the router and take an end mill and just clean these sides up a little bit, and that should give enough clearance. There's enough clearance on the bottom there, so I should be alright. This end looks like it needs to go down a little bit anyway, so let's get set up and do that. Might have to go a little deeper. I think just looking at this here, you can see where the drill bit kind of led off this way as it went down, because you're only cutting into the partial meat of the metal there. So anytime you do that, the bit has a tendency to lead off. Well, we've got the channel plowed out there. Let's see if it'll fit now. Well, it fits. May have to go a little deeper. I can't really tell if that's parallel to this edge or not. I think to be on the safe side, I'm going to go a little deeper and maybe just a hair wider. Make sure I got plenty of clearance. I trimmed it out a little wider and a little deeper, so let's see how she fits now. This other end seems a little tight. Seem to be hitting something, but this back end I believe is going to be alright. Plenty of clearance this way. I think I've got plenty of clearance that way. So I think that's going to be alright. I just got to see what I'm hitting here now. That's how it's going to sit in there like that. I've got to make a new plate to replace this one. So I have to get a, excuse me, a 15/16 -16 tap. That's what this thread is. And make a new plate here about an inch, well maybe about 3/4 thick to an inch thick, and span across here where I can put a screw here and here, tap it into this cast out past that hole there, and have 2 screws holding that plate on. And it can't be very wide because the motor head sits on here, spindle head, and there's not a whole lot of clearance there, so I'll have to double check to see how wide I can make that. But that'll be the next thing to do, make that plate and mount this in there, and then we can start working on the way to mount the motor at the top. I haven't quite got it figured out yet, but I think I've got a couple ideas that might work. So we'll get this part here done first and get this put back together and mounted on there, and then we'll see what we need to do at the top.